Hi everyone, in this video we're going to be looking at the Chapter 8 exercises and our practice with feedback questions here. And so looking at our first tab like we usually do, I think I'm going to let you all go through the notes or the materials, the book, etc. to be able to answer these questions here. But let's jump into some of the more calculation focused questions here and see if I can't help solve some of those with you. Okay, so here are exercise 2 problem here, and it talks about again, we kind of had a similar problem in class from this, but making berets with the wool, etc., how many berets we made using how many units of materials, what was the cost, and so on and so forth. So let's go ahead, and what I want to do in these problems is actually use kind of the template that we had used in class to analyze these problems that shows the different breakdowns. I think that's a valuable exercise to kind of have as we go through and solve these problems. It's a little bit tricky, I think, to try and do it all just within the one box here. So I'm going to switch windows now over to a separate Excel template. I'm going to make this Excel template available for you all on Canvas as well, if you'd like to use it. But if you want to just kind of follow along as well and make sure that you understand the logic here, that would be sufficient as well. So let's jump over to that separate spreadsheet now. Okay, so now we've got the spreadsheet that I was talking about pulled up here, and I'm going to take a screenshot of our question so we can kind of bring this over and paste this. Whoop. There we go. Kind of paste that in there so we can work through the problem as we go. And like I said, I think it's valuable here. And, you know, as with all the homework problems, you'll have a little bit of a different set of numbers, but I think it's valuable just to walk through the process of solving these problems off to the side here. That way, you all will have a better understanding, I think, of how to analyze these problems using kind of this overall template and be able to solve, you know, the problems on your own with your figures that you might get here for the same types of problems. So, okay, so let's take a look here. In this problem, like we were just mentioning, we're talking about creating berets out of special dyed wool fabric, and we've got a breakdown of how many units, basically, how many berets, right? It can be, when we do these problems, it really doesn't matter what the problems are, you know, what's being created essentially, and you'll kind of see that in some of these problems is that they are very focused on the specific, just with a wide variety of types of items that we might be preparing with types of just all sorts of different, you know, currencies, etc. Okay, so just download something here. Okay, so without further ado, let's start filling out our work problem here, just so we've kind of got these all listed out. And like I said, I'll show you how to fill out our template so that it can kind of help answer some of these questions for you that we're going to see within just the, you know, the answer boxes in our exercise. Okay, so let's go through, and based on what we know already, let's start filling this thing out. So we know that we have, remember, we have actual, we have standard or budgeted amounts. And that's really the crux of this chapter, and the analysis that we're doing here is comparing our actual performance when it comes to production versus our expected performance, or, you know, our standard. Okay, so we made 7,000 berets, number of units produced. We made 7,000, and we're going to go ahead and put that in both boxes here for standard and actual, because what we're going to end up wanting to do is to compare, if we had produced 7,000 at our standard rates, how would that, cost compare to what we end up getting versus actual, and whether we had favorable or unfavorable performance. Okay, so we really did use 7,700 decimeters of fabric. So our quantity used was 7,700. And it doesn't really matter. I mean, we need to be careful. We're having apples to apples when it comes to the cost per, unit of measurement that we're measuring. But here you can see we've got details of cost per decimeter. It takes this many decimeters. Here's, so as long as you're having the same units throughout, you should be okay. So our total cost of raw materials was 177,870. So 177,870 euros. So again, that's, currency essentially. I think if we want to be proper, we can go to currency and then find euros in here, I think. I'm not sure why I'm not seeing it, but obviously the euro is a very primary. There we go, euro. So which one is it? I don't usually use euros in my calculations. Okay, that comes after the end. So, I mean, it's not really a big deal to have this be right necessarily, but I just wanted to show you all that there is the ability to pick any kind of currency. It doesn't have to be dollars, USD, when it comes to Excel formatting. So anyway, so total raw materials and cost. And so here's what we know, right? This is our actuals. So let's take all our actuals out. And then we want to come over to our standards, and it talks a little bit about what our standards are. We see here that it says each unit produced requires 1.2 decimeters of fabric. So our total raw material quantity divided by number of units sold. So this, maybe I'm going to update that actually to just say standard raw material per unit. And this standard is going to be 1.2, like we mentioned. Here we can actually get the raw material quantity total divided. We can calculate this for real here and say how much did we use divided by total number of units. And so we used up 1.10. In reality, we used 1.1 decimeters per item produced. And here we were thinking our standard was 1.2. So right off the bat, you can tell that we're coming in on our materials usage. Quantity variance is going to be favorable because in reality, we use less product than we were expecting. So right off the bat, that's one thing we can see. But we'll come up with actual dollar figures there in a bit. Okay, and we had a total cost of a standard cost. And I'm going to, again, I had titled this, but I'm going to raw material. I'm just going to update these just a little bit as we go. So that makes a little more sense. It's a little better. Okay, so we said that was going to be 21 euros per decimeter. So I'm going to paint this just to get my euro sign coming over there. That's good. Okay, and then we can back into this number in reality of what we are actually, what was our cost per unit. And let me make sure I've got that. So 21 euros, yeah, this is 21 euros per decimeter. So I should say, so our total per unit then, I guess we should say, not exactly 21 per unit produced, but rather 21 times 1.2, right? Because it costs us 21 per decimeter, but it's 1.2 decimeters per unit produced. Okay, and then we're saying that we produced, or it cost us this much. and that was the total cost of raw materials here. And so if we want to find out our total average, cost of raw materials divided by, and I don't want to say quantity, I'm going to say per, divided by number of units produced. Oop, I want to say produced here as well. Get the decimals. Okay. And then, so if we were to produce 7,000 units, under our standard, we would expect to use 1.2 units of raw materials for every unit, total produced. That's just taking 1.2 times the numbers as it tells us for our standard. And then we could take that total. Well, there's two ways to do this, I guess. Since we already figured out how many units we produced and we figured out how much standard was going to be per unit, we can take that total and just multiply it by the number of units. We could have also taken, which should arrive us at the same spot. So if we said we had our standard quantity was 8,400 with the standard price here of just 21, then we should be able to multiply these. Maybe this would be a better way. Multiply these two together to get 176,400, which again is the same thing as taking the, if we had updated per unit produced as opposed to per decimeter, basically. Let's do it this way: per raw material. And if we want to do kind of the same thing here, let's divide by the quantity of raw materials. So we'll say total raw materials cost divided by quantity of raw materials. And then once we kind of get to this point, we essentially have all the information that we need to fill out the rest of our breakdown up here. And so we've listed out kind of as well, like all of the components down here. So we have actual quantity of raw materials of 7,700. And we want to take that number times the actual price. And so the actual price was 23.10. And so we get 77.23. Wait a minute, let me make sure I got that right. So total raw materials. Let me make sure this is right. 177, 23.10. Okay, there we go. Had that wrong. I was like, wait a minute, that should be the same thing. Sorry, I had a plus sign in my formula instead of a multiplication sign. So this is our total cost of raw materials in real life. And so that's that. And then we're going to want to take our actual quantity of 7,700 here times our standard price down here. So 21. Again, let's use our little format deal there. And so we are saying, so if we take 7,700, which is our actual quantity used, and we multiplied it by the standard price, we would end up with $21. And then if we take the actual quantity minus, let me make this formula here. So then if we take the actual quantity at the actual price and compare that to the actual quantity at the standard price, then we end up with a positive variance of 16,170. Get the decimals here just for the heck of it. And so it's a positive number, and we really need to kind of step back and think about, okay, does that positive number, what is that? Is that favorable or unfavorable from a business standpoint? And here we can say from the business standpoint that, and you can kind of look at this and see clearly is that the standard price was $21 per unit, but we ended up actually it costing us $23.10. So our actual costs were higher than we budgeted. So that's going to be an unfavorable variance. So I'm just going to put a U there to represent unfavorable. Okay, and then let's talk about the materials quantity difference. So we have our standard price of, our standard quantity of 8,400 and our standard price of 21 per, unit of, per decimeter, if we will, of fabric used. And then again, let's do the same basic formula of saying, okay, if we were at actual quantity times standard price versus standard quantity times standard price, subtract the actual from the standard, then we get a negative number. And let's step back and look at that and think about what that represents. Excuse me. And so in both of these problems here, SP is the same, right? That's our standard price. But what we're looking at here really is the actual quantity versus the standard quantity. And so we were able to make this many units with only 7,700 decimeters of fabric or whatever it was in this instance. And that was 1.10 decimeters of fabric per hat beret in this instance, unit produced. And we had a budget of 1.20 decimeters used. So you can already see we're using less fabric than we had originally thought. So that kind of jives with the fact that we've got a negative number here, which is a positive variance. In other words, we were able to save money because we didn't use as much on our materials quantity usage, essentially. Okay, so now let's jump back over to the input screen and take what we've got here and try to see if it gets us to get our red X's and all that. Okay, so here we are back to the back to the page with the inputs for our questions here essentially, and we've got our work already done off to the side, and that kind of helps us answer through all of these questions. So the first one says, what is the actual price of fabric per decimeter? And we calculated that out to be 23 euros and 10 cents. And again, that was by taking our quantity actually used divided by the total cost. What is the standard quantity given the number of berets produced? So our standard quantity would have been 8,400. That is to say, we produced 7,000 units, and if we had exactly met the standard that we have in terms of how much each one of those units will take, that would give us to the 8,400. That's the SQ in our little model that we just created. Okay, and then what is the amount of the materials price variance? That was our 16,170. That's our unfavorable variance there, and we can say here unfavorable. And what is the amount of material quantity, the efficiency variance? That's going to be 14,700. And we can say this one is favorable. Cool. So that all comes off of the spreadsheet that we just analyzed, essentially. And you can go in and kind of, like I said, download and do that yourself. But this helps us. I think this is just valuable. And in my perspective, it matches up with kind of what we have in the lecture notes, etc. And it allows it to be, just to view the problem a little more clearly. So with that said, let's do the second one with the same format. We're going to do, we are going to analyze labor in the second problem. So let's do that now here for exercise. Okay, now we're back to our analysis spreadsheet here. And so as you can see, this is where we kind of got a lot of our, there's the 2310, the 8,400, and then the different dollar variant, I should say euro variances. So just reminder, that's where those numbers came from on the other input tab. But now let's look at our payroll or our labor cost analysis. So that our first one was the materials variance analysis, but now we're going to look at labor. And I'm going to paste in a little spreadsheet, or sorry, a little screen snapshot here, snip so it's easier to see what we're working on. And yeah, as I mentioned in class, when we're thinking about the inputs to production, kind of think of those in a similar way as raw materials, right? There are obviously some differences in terms of the way the terms we use and things like that, but we're going to think of this very much as a similar in a similar way as we are with the cost of materials inputs, and hopefully that'll be clear as we work through. Okay, so let's follow a similar process here and just start filling out our template. And so we made 21,000 sandwiches, and that's our actual. We used 840 direct labor hours, so that's kind of like the units of the input, like we were just looking at if we were talking about raw materials, but the hours are the, quote unquote, like raw materials or input from our labor, if you will. And then we can say, we paid a total of 6,804, and it looks like it's just USD, so let's just do the $sign there. That's easy. Okay, and now let's go down to our standards, and we are, let's see, wage per hour standard. Okay, let's do currency, would be 9. And our hours per unit produced, this one we have to do a little bit of math. We talked about this in class about an example problem of having to sometimes do a little analysis, because we want to convert this, which is saying the employee should make 20 sandwiches per hour, into how many hours it takes to make one sandwich. So we can take 1 hour divided by 20 sandwiches would give us 1/20th. That's not helpful. There we go. This is it was on decimal, or sorry, ratio. But yeah, 1/20th, which is equal to 0.05 hours per sandwich. And if we were to if we wanted to convert that to, minutes, that what we're saying, in other words, is that we'd have 1 sandwich per 3 minutes. And if you were making 1 sandwich every 3 minutes, you'd be making 20 sandwiches per hour. So that's not really super important for our purposes of calculation, but being able to convert between the verbiage here of how many, units per hour we're producing, and then converting that into how many hours that is an important little skill to know how to do, because you might need to do that on certain problems. So again, that's just taking 1 hour divided by how many things produced gives you how many hours per individual unit. Okay, now we've got everything kind of input here that it told us, and we're going to go back through now and do some calculations of the rest of this information that we need. So the wages here was 6,804. The total hours were 840. So that means that in actuality, we were paying an average of $8.10 in wage per hour. So right off the bat, when we have that, we can see we're coming in under on our wages per hour. So that means we're going to have a favorable variance when it comes to the actual price that we're paying for labor. And let's see what else we need to do here. Okay, so let's bring over the number of units produced to our standard breakdown. And under our 0.05 hours per unit, we want to multiply that standard, speed, if you will, of production against the number of units produced. And that would tell us that if we were producing sandwiches every 3 minutes, then that would have taken us 1,050 direct labor hours. And we can see we're quite a bit under that, so that means that we're producing sandwiches, faster than 0.05. And we can figure that out by taking the number of sandwiches produced divided by the total hours, and we're doing 25. We're doing 25 sandwiches per hour in order to get the actual hours that takes to produce those. We would take the 1 divided by 25. So 1 divided by the number of units per hour. So we're making sandwich is taking us 0.04 hours instead of 0.05. And again, I kind of backed into that by taking the number of sandwiches produced divided by the total hours, which gives us how many sandwiches per hour, 25. And then another way to do that, which is what I basically just did, we could just take the hours divided by the units there. That's how we would get that. So if you want to know how many hours it takes, then divide the hours by the sandwiches. If you want to know how many sandwiches you can do per hour, take the sandwiches divided by the hours. So you're just kind of doing it one way or the other. Okay, now let's get on to our standard wages paid here. So if we had produced the 21,000 like we actually did, but we had paid at our average standard wage. Oh, sorry, per hour, not per sandwich. There we go. It would have been 9,450, and as you can, again, you can see we've come in quite a bit under that because our wage per hour was less than standard, and our direct hours are less than the standard as well. So that's favorable in both instances. Okay, and then let's just finish this out by taking our actual hours times our actual rate. Our actual hours times our standard rate. We got that. And then let's take our standard hours times our standard rate. And I just wanted to do some formatting. And then I'm just going to steal the same formula. Again, we're saying this minus this, or I can just do it here, I guess. That's this minus this. And then let's copy and paste so that this becomes this minus this. And as you can see, they're both negative. As we've previously seen negatives being positive, we're going to carry that same, outcome here as well. But we do want to step back and just make sure, whenever you do these problems, I recommend taking a breath and not just thinking it's always because it's negative. Because if you did have a change in which one you're subtracting from the other or something, you could accidentally mess yourself up there if you're not kind of slowing down and making sure that what we're talking about as far as the negatives being favorable is true. And some of that, I think, is just best done by looking like we just did at our outcomes of, in actuality, we were paying an average of $8.10 per hour, where our budget said $9 an hour. So we are coming in under budget, in real life in our actual outcome, and that is favorable. Same thing here. If it takes us less time to produce the unit than we had budgeted for, that is also favorable. So we can kind of see once we take a breath and step back from our detail, just to sanity check is one way to say that yourself, and make sure that you've put everything in correctly and that your outcomes are making sense. This does make sense that these are both favorable variances. We're coming in under budget, essentially. Okay, let's hop back over and input these values into the exercise tab, or the exercise document. Okay, now we're back over on the exercises document. We finished our whole analysis here. And I've got it kind of off to the side. And you know what I'm going to do on this one? That actually probably would have been good to do previously, but that's okay. Maybe I'll do that just to hear in a sec. I'm just going to do a little snip again to bring this over. Oh, you know what? Shoot, sorry. I don't think I can do that. No, it doesn't let us. Everything's too locked down. I was going to try and paste a screenshot here so we could compare and see where everything's coming from, but that is not allowed, so that's okay. Okay, what is the actual labor rate? So we went through and we analyzed, right, and we came up with an $8.10 labor rate. What is the standard hours allowed for the number of sandwiches made? So it would have been 1,050 hours. What is the amount of labor rate price variance? That was the 756. And again, remember we said that was favorable. And then the labor efficiency is 1,890. And again, that was favorable as well because we had an average salary per hour, or average wages per hour, were lower than what we had budgeted for, and also the average amount of time it takes to make each sandwich was lower than we had originally budgeted for. So both favorable, and things are going well for us. Okay, let's while we're working on these kinds of problems, I'm going to skip over to exercise 5 and 6 and use our template again to solve through these problems. And let's create a new template here on the other side, and I will jump over. Okay, so now we're back on this screen here. I'm going to just delete out all of this information, and we can do our inputs again. And the good thing about this template and these problems here, especially for exercise 5, for example, is that in exercise 5, it basically asks us to analyze both the materials price variance and the labor rate variances too. So we can use this same spreadsheet to do all of the things we need to do in this problem, essentially. Okay, so let's just put in what we know to start. Let's follow the same process here. So number 1, number of units produced right away. We got 2,800 Zippos using 8,120 kilos of whatever this stuff is, lobby. I'm not sure if that's a real thing, but that's what we're calling it. The total cost of this material is 71456 yen. So if we want to get real specific, let's see, yen. Where's yen? Japanese yen. There we go. Okay, now we have yen. So again, you can get any type of currency. It's just a matter of doing some Excel work. And great. Okay, so that's the cost. That's the amount we use. These are the amount of products we created. And let's see what else we got. Okay, so we have direct labor costs. So again, we're going to do some of that analysis down here. But we have some standards that we're looking at here. And the standards here say that we show each item that we produce, each Zippo is going to require 3 kilos of this stuff at a cost of 8 yen per kilo. Again, let's just do this now. I'm format painting all these cells so they'll be in yen when we get those in. Okay, I think that should do it. Okay, so it was 8 yen per kilo. It takes 3 kilos to make 1 unit. And then it talks about some other information about the hours. So let's just start with the materials. Zoom in a little bit. Okay. So let's do some of the calculations here. Total raw materials cost divided by the quantity. So this is our total raw materials that we actually incurred, divided by the quantity of raw materials that we used. And so we came out with let's do some decimals here, $8.80 total cost. So it looks like we're going to have an unfavorable cost, raw materials price variance. And let's see, raw material quantity total of 8,120 divided by the number of units produced. We've got 2.90 kilos per unit, per Zippo produced in this instance. And so we're coming in a little bit lower than our expected budget here. And so that is going to be a favorable materials quantity variance. So this should be unfavorable. This should be favorable. Oh, I didn't delete the U's and the F's, but that looks like it's still going to hold true. So let's finish this out and just make sure that's the case. Again, we can just carry over at the standard, and then our standard quantity at our standard budget here at this 2,800 units would have been 8,400 kilos in this instance. And then the total cost would have been the $8 per kilo times the 8,400. So at standard cost and standard usage, this is what our totals would have been. And let's go through and do the work of just filling out this last little part here. So now we've got our actual quantity used times our actual price. And that's that number there. And so that's great. Our actual quantity times our standard price, so our actual quantity times our $8 if we were going that route is 64,960. And then again, this is the SQ. The quantity times the standard price is the 67,200 like we had here. Okay, and then let's just take our actuals minus our budget. We get 6,496 yen difference. And then let's do the same here. And so that one should be unfavorable. That's what we expected. And then we see a negative yen difference variance here again. And that as we're doing the same types of calculations, and this one minus this, that gets us a negative number, which is favorable, lower cost than expected. Okay. So with that said, let's you know what? Sorry, let's do the hours while we're here, and then we'll put all of it together at once in the other spreadsheet. Okay, so let's take a look at our hours and calculations here. So let's do a very similar deal. We can just link up here. We actually had 2,800 units produced. Total actual hours was 10,080, I think. Yep, there we go. Total wages paid were 176,400, and that's the yen, 176,400. Okay, and then we're also given some standards. So we say company standards show that it takes 4 hours per unit, and it should be 15 yen per hour. I'm going to do the same thing here and pre-format these with the yen. Okay, I think that should do it. And then one thing we can do if we want to just populate this, we're going to have that at the same number of units produced. Okay, and then the wage per hour, so total wages paid divided by the number of hours, 1750. So we're coming in a little high on wages, so our average wage was higher than we had budgeted. And then we could take our total hours divided by the number of units produced, and we see 3.6. So that's a little bit favorable. We're a little under the average of 4 hours per unit. We're doing 3.6, so that's good. Okay. And then if we were to, kind of look at this from our budget perspective, if we had done the 4 hours per unit and we did doing 2,800 units, so that would be 11,200 hours. And if we did 11,200 hours times the standard 15 per hour, then we'd have 168,000 total units. Just trying to make sure we didn't have any. If you're getting large numbers, make sure we didn't have any decimals, if that might mess us up when we're putting our answers in finally. Okay, no. All right, and then let's just go through and do our AH times AR, our AH times our standard rate, so our actual hours times standard rate, and then standard hours times standard rate. And then let's take the actuals minus there, so to get a unfavorable labor price variance, which is what we expect to see since we already saw that our wage per hour was higher than our budget. And then I'm just going to copy and paste that in, take this same formula, this minus this. I'm not sure there's extra, whoops, arrows there, just deleting out the extra one. But if we take the the quantity or the efficiency, labor efficiency variance, right? We were using less hours of labor to produce a unit, so we were more efficient than we expected from our budgeting, and so we're going to have a favorable variance of 16,800 in that instance. Okay, so now we've got all this information here. Zooming out just so I can kind of see everything in one screen. And let's jump back over to our input screen, and we'll input our answers, and hopefully we can get the right. Okay, so here we are back into our exercise input screen, and we're going to go through and just start inputting. So the actual price of material per kilo, we got that to calculate as $8 or so 8 yen and 80 yen cents, or 8.8 yen. Let's just say that. I'm not sure what the correct terminology is for cents in regard to yen, but what is the standard quantity? So if we had produced at the standard, and how much would we have used? Would have been 8,400 kilos, right? That's what we're saying. Yeah, kilos. So 8,400 kilos. What is the amount of the material price variance? That was 64.96. Oh, let me make sure that's not 6496. Materials price variance. Uh-oh. We got something going funky. So that is all making sense. 64. Okay, let's come back to that one. What is the amount of material quantity efficiency variance? 2240. No. So interesting. Why is that coming out? I'm just wondering if I have a decimal somewhere that I need to incorporate that is not being incorporated now. 7146. And anyway, okay, so this one was favorable, remember? Or, you can look back on the video and see where these are coming from. The actual labor rate, let's jump down here, was, so the actual rate was the 1750. The standard hours allowed under the 2800 Zippos would be 11,200. And then the amount of the labor price variance, I got 25,200. That one came out right. And that was unfavorable because we were more yen per hour than we expected. The amount of labor efficiency variance is 16,800. That one is favorable. And then we're just left with this one that is not, that's being weird. So the MPV, so it's trying to tell us, so AP minus SP times the AQ. I'm just going to go back and make sure my inputs all look accurate there. So AP minus SP, the AP would be, and let's just do the formula of it. So the AP is 8.80. That's the actual price. And we know that because, we can even just link this above as 8, but let's just do 8.80. It's 8.80 minus the standard price, which was 8, times the actual quantity, which is 8120. So now it went away. So, I'm not crazy. You guys are seeing this here. That's the same answer. But it didn't like me putting the strict number in. So, anyway, that's the same result. So, our template, our format still makes sense. You can see that gets the X to go away, and it's the same number basically one way or the other. But sometimes you have to put the actual formula in, I guess, to get it to go away. So, go figure. These things can be a little glitchy at times. No big deal. For the most part, everything is always working very well. So I really like these tools. Let's spreadsheets here. Okay, so with that said, let's take a look at our next problem here. And again, we'll just do the same process and use our same template and solve the problems we're looking at here. All right, let's jump over to that. Okay, now we're back over to our spreadsheet here. I am going to do some changes to these are all just USD, so I'm just going to, wherever there's yen, I'm just changing that to US currency, USD. I guess this one could have, no, that's materials, cost, that should have been dollars there, quantity, cost, raw materials per unit, I think those are all, and then that's just quantity. Okay, and then I'm just deleting all this out because we're going to do new. I'm just going to select all of these that have showing as yen, change those to USD with the formatting, and then delete everything out so we can start fresh and solve our next problem here, which is exercise 6. Okay, let's paste that in. So in this problem, we're looking at this company that makes some random zollies, whatever the heck that is, makes it out of a special type of rubber. And let's go ahead and, and we've got some materials and labor variances that we're going to look at. So we're making 4,800 units, and the quantity of raw materials that we used was 10,080 kilos of rubber, and the total cost was $32.65, so $326,592. And let's see what our standards are here for producing these products. It is 2 kilos of rubber per unit, and that should cost us $36 per kilo. So it's going to be, 72, or is that 72? $72 per unit, essentially, because we're at two units. So, but we'll get there. Okay. Everything else in the problem talks about hours, so we'll come down and do that separately. But let's just stick to our materials variances. So we're hopefully getting kind of comfortable with this process at this point. And let's go ahead and look at our total raw materials cost divided by the quantity of raw materials used. And let's do our formatting there. So it was 32.40. So we expect to see a favorable variance in our raw materials price because we were able to come in at 32.40 per what are we looking at? Kilo of rubber versus what we expected to be 36 that they had initially, are budgeted for our standard cost. Okay, and finally, let's do our on the actual side. Let's do our raw materials quantity total. So how much raw materials did we use for all this? 2.10 kilos. So a little bit worse than what we planned for to be 2 kilos per unit produced. So we're going to have an unfavorable variance when it comes to our materials quantity usage variance. All right, let's finish our calculations here. So if we were to pull over the 4,800 units produced, then at our standard quantity of 2, we would have had, sorry, these are funny looking, too many decimals, but we would have done 9,600. We would have needed 9,600 kilos. Like I said, we had an unfavorable variance there, so we actually used 10,080. That's where we can see down the difference here. And the total cost of all of this raw materials at the standard price would have been $345,600, and we were able to come in a little under that because we had a favorable cost variance that we noted here previously. So, all right, let's go ahead and put all these in. So AQ times AP, so actual quantity times actual price gives us the actual total price. If we had done the actual quantity at the standard price, we would have had that amount. And then our the whole standard there would have been 345,600. Let's do our formula here to subtract those two, and then let's copy and paste there. Oh, and then let's reconsider our favorable, unfavorable. And so here we can see that our materials price came in with a negative, and that's what we expect to see because our calculated cost per unit actually came in under budget. We had $32.40 per kilo as compared to $36 per kilo we thought we were going to spend. So favorable makes sense there. And then in this instance, we see a positive, so that's an unfavorable variance, more cost. And that's also to our expectations because we noted that we ended up using more materials to produce each unit than we had originally expected with our standard quantity here of 2 versus 2.1. Okay. Okay, so great. That's kind of part one. Now let's go down and look at our labor analysis. Similar thing, we'll pull in our units, and then let's pull in what it tells us. So we have 25,920 direct labor hours. Let's see, what else do we get here? Oh, here's our direct labor cost, 233,280. So that's total cost, total hours. And then it tells us from a standards perspective, we have a standard labor time of 6 hours per unit produced and $10 per hour of average wage. Okay, so let's go back through now and do our actual wage per hour. So our actual wages divided by the number of hours. We get $9 per hour, so right off the bat we should have a favorable price variance because we're a little under our budget. And then we'll take our total hours divided by the number of units to get 5.4. So we should have a favorable variance when it comes to our labor efficiency as well because we're producing units a little bit quicker. We only need 5.4 hours, not 6 that we expected. Okay, and then let's just finish out the little part here. If we had 4,800 units produced, we would have expected, per our standard, to have that take 28,800 hours at a total cost of $288,000 if we had actually paid the average wage of $10 as compared to the $9 that we did pay. If we paid the standard wage of $10, that's what we would have had. Okay. And then let's just go through here and do our AH, or actual hours times our actual rate. Our actual hours times the standard rate. And then our standard hours times standard rate. And then since we already have these formulas in here, I'm just going to copy and just highlight it there and paste that in. And that's just going to put the same formula in place there essentially. Keeps picking up these extra arrows for some reason when I do the copy and paste things. Still leaving some of those out, and it doesn't matter if they're there, but it's kind of annoying. Okay, so we're looking good. So favorable and favorable. That's what we expect. As we said earlier, our price per hour for average wage is lower than expected, and we're creating these things faster than we had originally thought in our standard cost as well. And so we're looking great. And yeah, we'll jump back over to our input screen and put our results in and see if we get the correct answer. Okay, here we are back into the input screen, and let's go ahead and put the answers off of our calculations. So the actual price of material came out to $32.40. Oh, let me get in here. Cool. Okay, we got that one right. What's the standard quantity? The standard quantity would have been 9,600 kilos. The amount of material price variance is 36,288. And we noted that was favorable. The amount of material quantity efficiency variance is 17,280. That was unfavorable. Okay. The actual labor rate was $9. The standard hours allowed for the number of Zippos made was 28,800. The amount of the labor price variance was 25,290. Both of these, as we just looked at, were favorable. And the usage of the efficiency variance was 28,800, and again, favorable. So sweet. Okay, we got those all to work out. And that's, you can kind of see this problem here. We kind of looked at these separately, but then as we took them all together, it's kind of that combined analysis. So these problems are a little tricky. Hopefully my template here is helpful for y'all. I know I'm jumping back and forth, and hopefully that's not causing problems. I mean, you can pause the video if you want to take a screenshot of the answers, as you move back, just to kind of be able to compare that. I can't really do that for you guys here like I would wanted to, because I can't paste anything specifically into these Excel spreadsheets because they're locked down except for the inputs. That's how the answer checking works. But I will leave a copy of the template on Canvas if you want to follow along and input into there and practice. Couldn't hurt. And so with that said, that's most of the problems. But then let's take a look here at problem number 4 to finish this thing out. Okay, so in problem number 4, we're going to be looking at this budget to actual comparison, and we're going to kind of flex this thing so that it actually, when we do the budget to actual analysis, it is accurately reflecting apples to apples, not apples to oranges, because right now we have a budgeted 1,200 in sales, whereas in reality we have 1,500 in sales, right? So we're gonna take our actuals, but then we're gonna flex up the budget to be similar production, so we'll have the same number of units, and then we'll make the comparison. To start, let's go ahead and fill out the lines here. So we need to look at our variable costs. This is kind of just broken down by different sections of the income statement, but we need to analyze what is variable and what's fixed when it comes to these line items. So variable cost, 2 things are immediately true, is that the labor and materials are going to be directly proportional to production, and so those are obviously going to be variable. And then we also have packaging expense, which is going to be kind of that overhead cost, if you will, directly applicable to preparing getting the products ready to sell. And so the more you produce, the more cost of all of these you're going to have. And again, that's why this wouldn't make sense to directly compare this, because if you were to bump up your production to 1,500, or if you were just comparing it at 1,200, these costs are going to be too low, because those will just increase whether they're expected to increase with increased production. So, but the fixed costs now are going to stay the same. So we have a number of different things. We have depreciation. We have plant manager's salary. So that's a fixed portion of overhead. The packaging expense would be more the variable portion of overhead. We've got advertising expense and sales salary expense here. So we're going to have that sales as a fixed cost. And let's see. Okay, that's pretty much everything in there. So then let's just put our amounts in. So this is just coming straight off the above. Under salary, 40,000. And sales salary expense. And one thing to note, if it had said sales commission expense, that may more so be something we'd want to throw in variable, because if commissions are based on, the number of sales, that would change things in here. But it's just saying the salary, so it is noted as a fixed cost. Okay, so here's the big change we want to make, and again, these are gonna be the same. Or the same as our budget. We don't want to change those. When it comes to depreciation, we've got 5,000. When it comes to our plant manager salary, 40,000, and we are pulling these in from the budget tab. Advertising expense 12,000. So that one we were a little bit over, and that, just because it's fixed doesn't mean we're going to 100% meet that fixed budget every time. That's just something that doesn't flex with increased production necessarily. And then sales salary expense. And then we're going to take our budget minus our actual. I'm just going to do that formula up and down here. So we were over, and that's under budget on advertising expense. So that is favorable. And we are over budget on the sales salary expense. So that's unfavorable. So I'm going to leave it this way because I just want to highlight the fact that because you're going to see a negative or a positive, and remember in our other problems we've been looking at, you've seen the negatives as favorable. I kind of wanted to do it just a little different on this one because it's going to show you that it's not necessarily whether the positive or the negative is there. You really have to look and see what that is conveying. Is the budget less or more than actual? Right. And then be consistent if you're within one specific report so that you're not showing positives as favorable at one spot and negatives favorable in the same report. So watch out for that. Okay. So now for the direct labor and direct materials, the variable costs, we want, well, first thing, let's bump this up to 1,500, right? We showed 1,200 up here. And so I'm going to put a formula in that says, I'm going to do 2 parentheses. My formula is going to say, I want to know how much. So if I'm saying we had 108,000 planned direct labor costs, I want to know what that was on a per unit basis. So that'll be $90 per unit. And then I want to multiply that by the 1,500 to give me 135,000. So hopefully that makes sense. We're taking that original budget, getting it down to the per unit cost, and then multiplying that by the new number of units of 1,500 that we expect, or we're flexing to, so that when we're comparing these numbers down here, that we're doing apples to apples, right? This is what the cost would have been using our original expectations, but at a higher, sales number, essentially. Okay. I'm going to go, so I just went in to my little formula bar, copy, I get down into this cell, paste, and I kind of want to just do the same thing for all of these because it's going to be the same formula basically. So if we say direct materials, 72,000 was our expectation at 1,200. So let's divide by the 1,200 to get a per unit cost, and then again multiply by 1,500 to get the flexed, the increased amount there. Let's copy that formula one more time. And let's go in and do the packaging expense as well. So that was 36,000. Again, 36,000 total at 1,200 sales. So we're going to get a per each unit sold, but then we're going to flex that up to 1,500. And that gives us more of an apples to apples comparison there. And again, we don't do that for the fixed cost because the fixed is fixed, right? It doesn't change with increased sales like that. So then if we want to just copy these formulas, we can just go through and paste these all in. And at this point, we can kind of see, if we're following the same methodology and the budget to actual is the same. At this point, if we're comfortable with it, we can just kind of go through and, okay, negatives are unfavorable, positives are favorable. But don't forget what we're doing. Do a gut check still just in case, because in the real life or on the test, you're not going to have the X's that go away. So just make sure you know what you're doing right. So because what we're saying is the actual was this amount. If we were up to 1,500 based on our budget figures originally, we would have been at 135,000. So since we're coming in under budget, that's favorable. That's good. That's what we like to see. So that all makes sense. And then alternatively, if our materials costs are over what the budgeted amount would have been, that's, an unfavorable variance. So, okay. Well, hopefully that's helpful for you guys. Like I said, I'll leave tab 1 for y'all to kind of go through and compare these to the, shoot, you know what? I'm feeling generous right now since this was a long, tricky chapter. I feel like so I'll just do them with you here. If you stuck around this long, let's work on these together. Okay, so if we're doing these in this format, which is a little bit different than how we've been looking at things, with our templates and everything, but this is the actual kind of one line formula to get there if you're trying to find these different things. Is our first one is our variable. Oh, wait, no, we have actual hours minus standard hours. Oh, times the standard rate. So if we're doing the standard rate and we've got actual hours, that's going to be talking about the labor efficiency. So we're looking at labor. So we're saying actual minus our standard. So how many hours did we actually use? And then we can, let's go on to the next one. So here we're saying actual price minus standard price times actual quantity. So here we're going to be talking about the variance between our actual prices of materials. And so that's going to be our materials price variance. The actual quantity minus the standard quantity is more about material usage or quantity efficiency variance. Our actual variable overhead rate minus our standard variable overhead rate gives us our variable overhead rate. Where am I not seeing the? Oh, I'm missing something. Here we go. Sorry. Variable overhead rate variance. We didn't do a lot of calculations with that one. That's a little more tricky, and so we basically just don't focus on that too much in this class. But when you guys do cost accounting or future managerial accounting classes, you'll probably run across that possibly in the future. For the test, you'll do more like what we've done in class and in this assignment. Okay, actual hours minus standard hours times standard variable overhead rate. That's going to be how efficient are we in applying our in the overhead efficiency part. Similar thing, not something we specifically calculated out, but that is what we were. That's what this formula is doing. Won't be on the exam, like I said. So, difference between actual overhead cost and actual cost applied to work done would be our total overhead variance. So we can have total variances, right? That's the combination of the efficiency and the rate differences. And we kind of have those under all the different ones as well, whether that's materials and labor and overhead. So optimal level of performance under perfect operating conditions, that would be like our ideal standard. Again, that's not like a reality that we expect to hit, exactly. We'd have to have like a crystal ball to know the exact future, but it's just a development tool that we have and an analysis tool so that we as managers are able to assess, business performance as we go. Efficient levels of performance under expected conditions is more of the practical standard. So not optimal, but efficient. And then the actual rate minus the standard rate is going to times the actual hours. So here we're talking about hours and rates. So we're talking about labor, and this would be just the rate variance as opposed to the actual hours and the efficiency variance we noted up here. All right, I got 100%. So hopefully this chapter is not too challenging for you all. And I know it's a little bit of I think it's a tricky chapter with kind of a lot of things going on. If you're able to kind of step back, and take a breath and know that the concepts, maybe it's not as hard as it seems. I feel like there's a lot of terms and a lot of this times this and formulas and all that stuff. But if you can kind of step back from all the formulas and the numbers, to some degree, and try to focus on what it is that we're doing, which I hope that the template that I showed you and we worked with helps you do that, then my hope is that this chapter becomes a little bit more, and this material becomes a little more digestible for everyone and memorable when it comes to test time, etc. So, all right. Well, thanks for sticking with me on this one, everybody. And like I said, I'll upload a copy of the template there for you to use if you'd like. And hopefully you learned something in this video, and I appreciate you following along, and I'll see you in the next video or in class. All right, have a great day, everybody.